Welcome to the Pathfinder's Codex. Today we're diving into the fascinating world of cellular automata, with a goal of having a functional prototype of Lenia life in Godot. This video, the first of 3, will walk you through the early stages of my journey, showing a few of both the successes and intriguing failures so far. Stick around to the end for info on the next Lenia video. Have you ever wondered how complex lifelike patterns can emerge from simple rules? In this series, we'll explore just that by recreating Lenia in Godot. Let's look at some of those early prototypes and experiments. Initially, I began with a game of life simulation, which many of you might be familiar with. It's a classic example of cellular automata where simple rules lead to complex behaviors. While this was fascinating, I quickly pivoted to the more sophisticated world of Lenia and the concept of smooth life, drawn in by the fluidity and organic nature of its patterns. This transition opened up a whole new realm of possibilities and challenges in simulating lifelike behaviors. Lenia introduces the idea of kernels, mathematical functions that dictate the growth and behavior of cells. This makes the patterns more fluid and organic compared to the rigid structures of the game of life. In my early experiments, I played around with different color schemes like grayscale, red-blue scale, jet, and plasma. Each scheme brought a unique visual appeal to the evolving patterns. Applying kernels and calculating growth during convolution was the next step in the journey. This process involved using mathematical functions to determine how cells interact and evolve, which added a layer of complexity to the simulation. The challenge was substantial and many of my experiments didn't go as planned. The biggest issue was that GDScript, the scripting language in Godot, isn't optimized for these heavy computations. As a result, even medium-sized grids ran slowly, hindering the simulation's performance and responsiveness. This limitation forced me to rethink my approach and explore alternative solutions to achieve smoother and faster execution. To overcome this, I considered integrating the MathNet numerics library into Godot. This approach is much more involved than simply using GDScript, as it requires a custom compiled version of Godot to support the integration. This could be a topic for a later video, as it opens up new possibilities for optimization and performance enhancement. In the meantime, I added simple multi-threading to speed up some of the more loop-heavy processing. By using a divide-and-conquer approach, I was able to distribute the workload across multiple threads, which helped improve the performance a bit. However, there's still room for improvement as the simulation grows more complex. As I continued exploring ways to optimize the simulation, I ventured into using fast Fourier transforms, or FFT for short, despite my limited knowledge. Implementing FFT in GDScript was tricky and isn't fully optimized yet. Luckily, there's an asset library plugin that gives us the basics. It only works with grids that have side widths in powers of 2, adding another layer of complexity. Also, the handling and conversions of complex numbers in Godot was shaky at best. I think I got it working mostly. Another challenge has been dealing with kernels that aren't radially symmetrical, leading to strange edge effects. These presented as different shapes and anomalies around the outside of the grid, and would act differently when using smaller versus larger grids. These are issues I'll be tackling in a future video in the series. Throughout the rest of this video, you'll see a series of sped-up clips showing my various prototyping attempts and the interesting, sometimes beautiful accidents that occurred along the way. From basic processing of a cellular grid, to smoothing of values, to using kernels and applying convolution over time, these experiments are a crucial part of the journey to creating a fully functional Lenia simulation in Godot, but it's not ready yet. In the next video, I'll introduce a more polished UI and optimize the code further. We might not have a perfect Lenia simulation yet, but by the end of this series, we aim to create a visually stunning and educational tool running in Godot. I invite you to share your thoughts, feedback, and ideas in the comments below. Your input can help shape the development of this hobby project. Thanks for watching, and stay tuned for more updates on this exciting journey.